Welcome to another RDWorks Learning Lab. After our recent session on engraving glass, I had this little package from China arrived. Now, it arrived too late for me to examine the glass samples that we did. So any conclusion that I came to was based on my very poor eyesight and just a subjective judgment. Now that I've got this little piece of kit here, I've looked at those samples in more detail, and I think you might find the results rather interesting. Let's just start off by very quickly explaining how glass engraving works. It's a bit like a stone hitting your windscreen. That's the sort of effect that we're getting, but instead of doing it with the energy of a stone, what happens is you fire a very small point of energy at the glass. The glass heats up very, very locally and expands. And it expands so rapidly that it actually breaks away and shears away from the background glass. So you get these lots of little stone chips all over your glass surface. And basically that's what this first picture is. This is a close-up picture of just ordinary dry glass engraving. And this second picture on the right is what happens when we use washing up liquid to protect the surface. Now I'm going to leave the bottom left hand picture for a moment and we'll go to the bottom right hand picture. Now that is what happened to the glass surface when I coated it with molybdenum disulfide. I can't explain what's going on except that it's a completely different texture. These were all done in the same lighting conditions, so there's no argument that light is having an effect on this picture. It's a completely different texture. Now that's something that I couldn't see with the naked eye, and I think this demands a lot more testing because this is a very interesting discovery. The picture on the left hand side is the Surmark. Now Surmark works in a completely different way. It is not an impingement and etching process. It is a coating process, almost like a glazing process. The idea being that you coat the surface with this Surmark and you effectively burn a glaze onto the surface of the glass. So you can clearly see all the sweep lines on here. So this session will be all about checking a range of settings for Surmark on glass and also a range of settings for molybdenum disulfide on glass. And then we can come back and examine the results and compare them with what we can see here. So I'm very pleased with my little microscope. It does a fantastic job. And I only paid about £35 for it. Okay, now a guy in the States that sent me the glass Surmark also sent me a matrix file of his tests. RDWorks Issue 11 would not open the file, and also Issue 16 would not open the file. So I've downloaded the very latest issue, which is Issue 18. Several good things I have to report. One, the file is opened, as you can see. And secondly, there are lots of layers on this file. One of the great things I can see immediately is we've got filled in characters. Now I'm hoping that filled in characters indicates that they're going to be etched. So what I'm immediately going to do is go to the black layer and open the black layer up. And it says that it's a scan layer. Well, let's just change that to cut for a moment and say OK. And wow, look, so this is now a cut, and this beside it is an etch or a scan. So we've now got an obvious separation between these two modes of operation. My machine is different than Adrian's, the guy that sent this to me. And now what I want to do is to modify these values very slightly to suit my application. 15%, and I'm going to change that to 13%. And I'm going to leave the speed at 20. Okay. And I need to obviously go up to here. Hello, where's my black layer gone? It's down at the bottom for some reason or other now. And I'm going to change that. Oh, I've already to 13 and 13. 13% on my machine is the top of my pre-ionization phase. So I want to do some test work there, which is where we started off last time. Okay, and here we can see the black layer. It's 13, 13 and 20, which is great. It's a summary. So now I want to change this both speed and power. I change this again to 13%. We want to push this up to a speed of 50. Okay. Now I've just spotted something here. Look, it's turned black. That's because I had the black layer button pressed. Now you can't see that black layer button pressed because it's not obvious. What colour was it before? I can't remember, so I shall have to go and do a Control Z. So it's one of these browns. Which brown is it? I think it's the orangey brick orange, which is that one. So let's press that one, and we'll change this again now to 13%, and now we've got the right colour. So there's trap number one. You've got to have, to do the editing, you've got to select the colour that's on the text. But selecting the colour on the text, for some reason or other, when I select that colour, it hasn't selected it up here. So although I've selected the brick coloured or orange coloured layer, it hasn't selected it for here. I mean, I didn't select that colour at all, so why has it gone to that colour? That's totally illogical. Now, one of the other things that might be possible to do, so here we've got a blue layer and it's all set correct, 100, 13, 13. Now we've got this navy layer, so let's go to the navy layer, and I want to change that to a speed of 200 and 13, 13. Now this might be quicker because without pressing the OK, I now want to go to the next one down, which is the red layer, which is that one. I'm going to change that to a speed of 20, which is correct. This time I want it to go up to 15%. 15, 15. OK. Now the question is, I pressed OK there after 2 modifications. What I'm really checking is whether or not I can do all the modifications in there without keep pressing the OK button. So let's go and check whether or not that has changed. So that's good news. I can do all my editing of speeds and feeds in this list, and at the end just press OK. I've not explored any further into issue 18 at this moment in time, but that was just a first impression. I don't know what else they've changed, but they've changed things in here, but in my opinion it's certainly not for the better. What would be really nice is if you could click on that blue text there with the left hand button. It brings up edit the text, which is editing the feature itself. If I did the right hand button, what happens? Nothing. So there's absolutely no reason why they couldn't use the right hand button to bring up the blue parameter menu. Okay, so bitching over, the file is modified. Let's go and do some testing. I've got a 50-50 mix of acetone and the Cermark here, and I'm just going to paint a fairly thin layer onto glass. Right, now it's not exactly the best way to do it, but hopefully that'll be okay. And then next to that we've got our molybdenum disulfide spray. Now it's probably about 26 degrees here today, so it's not taking long to dry, as you can see. But because I'm a fairly impatient person, we'll give it a little bit of help. We'll do the molybdenum coated glass first. So I'm doing these first 4 tests using the top of the pre-ignition zone on the tube, which for me is 13%, which is about, I believe, 18 watts. Although you can't really call it 18 watts because probably there might even be 50 or 60 watts or even more going down into that glass in very, very short pulses of around about 3 to 3,500 times a second. Here we go, 100. So this is 50 millimeters a second with that high impact pre-ionization zone on the tube. And you can hear how hissy and noisy it is. Now we're up to 200 millimeters a second. Here, this is a much longer hiss. This has gone back to normal beam. Well, this is a bit like watching paint dry as opposed to stripping off moly, so we'll come back to this when it's finished. Now 30% is about 52 watts. Now that's a hell of a lot of power to be going so slowly on glass. I'm almost fearful that I'm going to crack the glass shortly. Now this next test at 40% is going to be putting about 60 watts into the glass at a very, very slow speed. This is getting a bit dodgy. Well, we're now putting about 60 watts into that glass at very low speed. So we can, when that 4 goes in, you can hear it's pulsing. Can you hear the bar of that 4? And that must be the special mode that I'm in for scanning. Well, the glass is not in, yes, it is just a little bit warm. Well, I would normally put my acetone on there and take the molly slip off, but what I'm fearful of doing is rubbing molly slip into the grooves or the little pockets that are in the engraved glass. So I'm going to leave that as is at this moment in time, and we're going to examine the finish straight off the laser. Now I just want you to look at this from a distance, because if you look, the first row is a little bit cloudy, and when we get to speed it goes white, and then it goes slightly yellow, then white, then yellow and white, very yellow, white, even yellower and white. So speed is definitely having an effect on it. I'm sure the brush marks won't affect it terribly. That might be slightly uneven, but we're not worried about unevenness because we're not going to sell this product. Now I don't think there's going to be a great deal to see on this one, so we'll just leave this working away, and we'll come back when the job is finished. So we'll also run the same test on dry glass to see what the difference is, just in case the glass itself makes a difference. Nice halo around the glass, isn't it? Well, I think you can clearly see here that at low wattages, say up to about 52 watts, starts to change at about 50 watts, I suppose, but certainly down below 50 watts these are fairly pathetic. Now bearing in mind they were all coated evenly, not very evenly, but they were coated this way, not that way, so if there's a problem it would not be this way with the coating. You can probably just see some of the streaks in the coating this way. So I think it's fairly conclusive that what we're looking at here is a product which requires quite a bit of heat to fuse it onto the surface, and it almost looks as though it needs definitely at least 50 watts, and probably 60 watts is the right sort of value. And you can see at 60 watts it doesn't matter whether you go 20, 50, 100 or 200, you still get more or less the same quality of result, and the same applies to these 50s, it's regardless of speed. But we will go and look at some pictures to see exactly what's happening to the surface of these. In the pictures that follow, the 18 watts top left hand corner is always my high impact engraving, and then all the rest are wattages as they are shown. Now this is plain dry glass, and I think as you can see in all of these pictures the glass seems rather burnt. All these are done with special mode engraving, which I think is probably a frequency engraving anyway rather than a continuous engraving. We start moving up to 50 millimeters a second, and there's a bit of an improvement in the 43 watts, but all the rest are still very badly burnt even though we're traveling at 50 millimeters a second. We get to 100 millimeters a second, and now the 43 watts is looking much closer to the impact engraving. We've still got some burning on the 65 watts, and now we get to 200 millimeters a second, and they're all looking pretty damn good. Now we get to the moly. Now the moly is completely different. It's not transparent, but they're still burning on the last three. Still burning on the last three here, but the first two are lovely and bright and white. Now we're getting up to 100 millimeters a second, and the coloration is going from the last three, and they're all becoming whitish. And then we get to this last one, and of course they're all nice and white, but there's some really good definition on the beam. Well, I think this last set of moly pictures gives us a bit of a clue as to why the moly is working so well. I think it's probably absorbing some of the heat energy, and it's not allowing the glass to crack and shatter as much, because if you look at the run out at the end of each of the stroke, the over travel if you like, it's lovely and clear and crisp, whereas we don't see that on the glass. So it means some of the energy is being absorbed by the moly, and I think that's the reason why we're getting a nice clean cut. Okay, so now we'll move on to the Surmark. What we're really doing is looking for the transparency here, I think. So we look at the background that's coming through, and we find that the last three are generally fairly dense. It's the first two where you can see some of the background through. We get on to 100 millimeters a second, and we're getting some background coming through on the last three high power ones. And then when we get to 200 millimeters a second, they're all pretty transparent except the last one at 65 watts, which is rather interesting. Let's go and have a look at them in reality. Okay, now let's take a look and compare these directly against each other. Now this is the moly, and I have to say that it's got a grey look to it. It doesn't look very pretty. It feels absolutely superb all the way down to probably these 50% power, which is about 65 watts. But smooth it might be. A nice texture, yes, but not pretty. If I was going to produce some sort of anniversary gifts for somebody, then I think I would undoubtedly use this high impact engraving at either 20, or because it doesn't look any different and it would be faster, I would probably use the high impact engraving, which is about 18 watts at 50 millimeters a second. Now a slightly softer and more transparent look would be here at 100 and 200 millimeters a second. But when we move into the 20% power, which is, as you can see, 43 watts, the beam is on fairly solidly, and it starts to burn the glass, and you get it's a slightly yellowy look to it, and that yellowy look becomes much more apparent as you burn further and further with the power. So I don't think that dry glass works very well if you've got a solid beam. It's sort of as okay here. I mean, it's not much different here at 20% with 100 and 20% 200 speed, as opposed to the 13, as opposed to the high impact engraving at these faster speeds. These are comparative, but given the choice, that would be the clearest one that I would go for. Now it's rather interesting when we get down to this Surmark, because the densest ones appear to be down here at 60 and 65 watts with, doesn't matter what the speed is, they all seem to be quite dense. Now that wasn't what we saw with the microscope pictures. When we looked at the microscope pictures, these were looking quite transparent. But I think the reason for that is because you can't see that on the video, but across here the Surmark is very slightly raised above the surface. But once we start getting to 20%, there's just a hint of flatness, or even a little teeny weeny ridge in the hollow bit in the middle of the characters. And as we get down to 30, 40 and 50%, I mean down here at 50%, it's almost halfway through the glass. You can almost feel that you've got like a ridge on the outside of the letter and a hollow in the centre. And maybe that's what that transparency is. It's actually dug its way and etched its way right into the glass, and then
put the filler on top of it. So it's like filling the etching. Whereas this remains hollow, that's got a fill. It's an interesting result, but to be fair, on glass it doesn't look very nice, I don't think. I think the white look is actually a better look. So I don't think I should be investing too much time and effort in Cermak on glass. I shall stick to high impact engraving, low power, high speed, one of these three. So a very interesting set of results, and I hope you can benefit from this as well. Now, although I've put the powers down here, it won't make any sense to you guys if you don't have a power meter and you can't relate these percentages to actual watts. So you'll have to make up your own mind about your own machines, I'm afraid.